And now, I believe our next presenter is ready. Take it away, BCIT.
Good morning, everybody. So my name is Phyllis Chong, and I'm from BCIT, and today I'm going to be talking to you about civil engineering. Before I get started, I just want to ask you a quick question. What do you think an engineer is? What are some of the words that you have associated with engineering and engineers, and what are some of the words that you might have heard associated with engineers? Right now, if you're wanting to contribute, please write your response in the chat. Remember to leave the chat as uncluttered as possible. So I'm looking forward to hear your response, and I will tell you a little bit about myself while I give you a chance to type into the chat. So I have been working at BCIT as an instructor in civil engineering for a while now, but before that, I actually spent quite a lot of time practicing engineering in the industry. My background is a civil engineer, and I specialize in structures, specifically bridges, and I have been working for over 15 years as an engineer, both in industry and teaching. So some of the more interesting things that I get to do as an engineer is I attend conferences near and far. I have been to Germany. This is the photo from when I spoke at a conference in Germany, as well as even here locally in Vancouver downtown. I also get to travel to places that I normally wouldn't travel to. So this is when I was on a job site in Chase, BC, in the interior of British Columbia, looking at one of the overpass structures. I get to meet all sorts of people and look at all sorts of different interesting things. And I also get experiences that I would never had if I was not an engineer. So for example, I actually had a ride in a helicopter on one of the job sites in northern BC, New Prince George, where we went to look at a site where we were going to put a bridge that was going to cross the river that you see here. And then, of course, I get to follow up with what is happening with the construction. Finally, from seeing the site unhindered until we get the bridge structure put in place. So in this photo here, you'll see that the photo at the top is a photo that I took from the helicopter ride of the river in the wintertime. And then some years later, when the bridge was fully installed, you'll see that as the lower photo. And that was again taken from a helicopter ride. That time I wasn't on the helicopter, unfortunately, but I was given this photo to show that the bridge that is in place. And you'll see that as the white structure there in the photo. Another part of what I do that I really enjoy is outreach. Some of you might have seen this and recognize this. This is actually from Science World at last year when we were able to install a exhibit on sustainability and zero energy buildings. And this is something that was actually installed at Science World, and it gives a chance for people of all ages to interact with science and technology, and that is something that I'm very passionate about. As part of my outreach, I also get to go to classrooms and speak to children and inspire everybody to grow up and love STEAM. Whether you're actually going to be actively participating in the STEAM career or not, you're still going to be impacted with STEAM some way or another throughout your lifetime. And again, you might recognize that photo. It's also from Science World, where I was able to take my son and his classmates to Science World on a professional development day and actually play around with building bridge structures of our own. And then, of course, as Dr. Bonnie Henry has mentioned, I do also have an inner nerd that I like to channel. So every time I go traveling, I look for bridges that I may have worked on in the past, or my company have worked on, or just interesting bridges in general. And I get to get my nerd on and actually take photos with all of these iconic structures. So hopefully that has given you enough time to give me some suggestions as to what you think of when you think of an engineer. Cindy, if you would help me out and let me know what some of the responses are.
Phyllis, can you hear me?
Yes.
Okay, excellent. We had a lot of responses in the chat. I got some people saying builder, some people saying designer, architect, fixing things, making things, all sorts of things like that.
All right. So those are really, really good ideas, and those are all true. But on top of that, I'm going to give you some maybe more towards the adjective side of what I've heard how people have described engineers. So one of the things that people might say is engineers are smart, they're logical, They're very practical. They're great problem solvers. But sometimes you also hear some not so nice things. You might hear people say engineers are introverted or passive or maybe even boring. But I would like to offer three other words that I actually think is going to very well describe an engineer. And these are the words that you should be thinking about if you are interested in a career like this. So the first word is helpful. Engineering is actually a very helpful profession. And as you'll see, as I talk about in my later slides, being an engineer is going to actually help transform the environment around us so that we can better work with the society and how we can better use our natural resources as well as the built environment to progress society. Engineers are innovative, and we need to be coming up with all sorts of new ideas such that we're not stuck repeating the same ideas over and over. And this is the only way that we as a society can grow and better be stewards of both our environment and our future. Engineers are also highly collaborative. That means that we're going to be working with a lot of different people from all walks of life, from all sorts of professions, all sorts of careers. And every engineering project, as you'll see, is going to involve a lot of different people. So some of the engineering definitions that are from some dictionaries as well as online resources I'm going to share with you. One of the ones that I found was from Oxford Language Dictionary, and it describes engineering as the branch of science and technology concerned with the design, building, and use of engines, machines, and structures. Another definition, the application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful to people, the design and manufacture of complex products. And then this one that talks about the root of the word engineering. The term engineering is derived from the Latin ingenium, meaning cleverness, and ingeniare, meaning to contrive or devise. And this last one, engineers figure out how things work and find practical uses for scientific discoveries. So all of these definitions have some things in common. It has to do with design, it has to do with being innovative, creative, and also being problem solvers so that you can find practical uses and solutions to better society. This next slide that you'll see is a word cloud that our department at BCIT have put together as what we think is going to be very important for somebody going through our program and then pursuing a career in engineering. So you must be practical, you have to be industry oriented, you have to be very professional, you have to display excellence, you have to be a problem solver, you have to be a critical thinker, you must be ethical, you must be looking to the future, and so on and so on. Now I come to this next slide where I'm again going to be asking for your participation. So again, when you have any responses that you want to share with us, please put that into the chat. You see a beautiful photo of downtown Vancouver, and I want you to think about what types of civil engineering may be going into a built environment like this. I'm going to show you, as you think about that and put it into the chat, I'm going to show you some different examples of areas of civil engineering. So the first one I want to talk about is structural engineering. Structural engineering is basically anything that is a structure. And some examples of that are iconic structures like towers and buildings and bridges and houses and high rises. So those are all part of structural engineering. There's municipal engineering and services, which would include water treatment plants, wastewater, how water comes through the pipeline to you in your home, and how your waste is then exported from your home to get treated such that it could be safely put back into the environment. There's transportation engineering, which is going to involve any type of mass transit, roadway design, or transit project. There's geotechnical engineering, which involves anything to do with soils and foundation. It even includes tunnel engineering. There's water management engineering, which deals with all of our water resources, so all of our natural lakes and rivers and seas and how they interact with our structures. So an example that you see here is, for example, how water in the river flows around the piers or the towers of a bridge structure. It involves building culverts so that you can carry waterways safely over, under, or around our built environment. It involves construction engineering, which will be involved in any type of uh, um, engineering project because as long as it's something that needs to get built, it needs to be scheduled by construction engineers as well as designed to be transported and constructed on site. There's also, of course, environmental engineering, which also is going to be part of every project because everything that we build is going to impact our environment and we need to think about that carefully. Coastal engineering, because in Vancouver especially, we do live on the coast. We are always going to be impacted with all the forces of nature that comes from the coast. How do we protect our infrastructure from those forces and how to better harness those powers that we have? Seismic research and engineering is to do with earthquakes. So again, because in Vancouver we live in a high seismic zone, we definitely need to account for how to protect our infrastructure from those large forces of nature. Materials testing and engineering. So anytime that we're going to have anything that's built, we have to think about what types of materials to use. How do we improve upon those materials and how to now use those materials for future? That includes materials such as steel, concrete, and wood. So coming back to the slide, I'm again going to ask for Cindy's help in letting me know what sort of ideas that you have about this particular view of Vancouver. What are some of the areas of engineering that might be involved? Cindy?
Sorry, Phyllis, would you be able to repeat that question real quick for a second?
Yeah, actually, I hear you quite quietly. I'm hoping that the audience can hear you well. But the question was, I had posed the question to the participants, what they see in this view of Vancouver that they will relate to the different areas of engineering.
So we definitely see a lot of coastal engineering as Vancouver is on the shoreline, some structural engineering in the bridges, and perhaps even some seismic engineering to keep the building standing in the case of an earthquake or some sort of seismic event.
Obviously, we see some of that. Structural engineering, we see the bridges, we see the buildings. Of course, the materials that go into constructing all of that, including the roadways. Seismic engineering, as Cindy mentioned, is going to be protection of our infrastructure against earthquakes. Geotechnical engineering, you don't actually see it in this photo because it's all underground, but all of our buildings and bridges need foundations as well as slope protection if it's something that's going to be built alongside a slope. Municipal services for water and wastewater. Again, you don't see that because that's our underground infrastructure, but very important for getting water to your homes and taking waste away. Transportation, so in terms of public transit and also roadway design, as well as even areas that are designated for pedestrians or cyclists. Coastal engineering to protect our infrastructure from those forces. Environmental engineering, as I mentioned, is obviously woven into all parts of our design. And construction management. So anytime anything needs to be built, that's what you need to think about. So engineering, in terms of a project, we always have to think of four major aspects. Number one is the function of that, which would mean how that product is going to work. How well is it going to perform for your needs? So function is addressing your needs with the design. Aesthetics is how nice something looks. So if you're going to build a bridge, are you going to build a very simple bridge, or are you going to have a more complex or more aesthetically pleasing bridge? The cost, obviously, that's going to be something that's important. And then last but definitely not least is sustainability, which we have to think about all the time. Sustainability is the ability for us to continue the way that we're going with our designs, which means that you have to think about the environment, but you also have to think about social impacts, such as whether or not this is going to be something that will be accessible for people of all abilities. Is it going to be including mass transit and other forms of transportation, and so forth. So thinking about these four important things in engineering, I have a little breakout for you, and hopefully you have already seen the link before. If not, I believe Hannah's going to be putting the link for this particular little game called Bridge Builder into the chat function. And this little game is going to allow you to try to play around with balancing those aspects. How do you design the most cost-effective bridge to span a 20-unit gap? And this is actually level 3 of the program if you have already played around with the program, or if not. I've heard that this program works better maybe in um, Microsoft browser versus Chrome. It works on my Chrome as well, but so I don't know. And so if you haven't played with it before, you're welcome to start with level 1. If not, if you have played with it, please work on level 3, which is the 20-unit gap. And I do look forward to some of your responses on how well you're able to design that bridge, balancing those major aspects of function and cost, especially in this scenario. I am going to show you an example of the forces in play in a bridge structure while you are going to be working on this for a couple minutes. And then I'll come back and ask for your solutions as well as show you my solution to this design. Okay, so I'm going to turn off my screen share for a little bit so that you can better see my screen here. So here I'm going to be talking to you about some forces while you're going to be working on that bridge program. The first thing I want to talk about is if you are building a bridge and you want to be spanning a gap, you want to think about the length of that. So let's say the gap is about this wide, so you're going to have to span that. If you're going to use a very simple beam, so just a single line structure, you can see that if something were to come along, if a vehicle was going to come along, and it's going to go along this beam, you're going to get some forces in here that's really going to bend that beam. And you can see that this particular beam now is actually quite deflected. How do you make this stronger so that it doesn't collapse when something larger tries to cross this gap? You can try to think about different shapes that might provide a stronger system. So one of the shapes that's commonly used in engineering is a triangle. So this is a triangle shape that I put together as part of a truss structure for this bridge. And you'll understand, or you'll notice that if you have a triangle shape, if you're now trying to push on it, yes, it still deflects a little bit and it bends, but it's going to take a lot more force and it's going to deflect actually a lot less. So it's actually going to bend a lot less. So triangles are very, very strong shapes to use. Thinking about that, you can actually extend that to an entire bridge structure. And here, my son did ask me to give him a shout out. My son, Russell, helped me build this bridge, so I'm giving him a shout out. In this bridge structure, you'll see that number one, you have to meet the function. So you have to span the gap. So you'll see that it's going to be sitting on these two, what we call abutments. The gap is going to be spanned in this direction. You'll see it's also functional such that there is a clear deck so that a vehicle can actually drive through this bridge structure and come out on the other end. And you can see that this is going to be very strong in bending because it now has a lot of different triangles to hold this in place. You'll see that when you're pushing on it, you'll still see that this bottom chord, this bottom line is going to be wanting to be stretched out, extended, and this top part is going to want to be compressed, pushed together. But at the same time, you also have all of these diagonal members and vertical members to help with that force distribution. You can try this out with an eraser if you have an eraser at home. If you bend it, you'll see that the bottom of that eraser is actually going to be stretched out and the top is going to be pushed together. So the bottom is in tension and the top is in compression. So again, circling back to the fact that engineering is a helpful profession, you'll see that in bridge building. That is a prime example because bridges are going to span two communities. It's going to provide a lot of connectivity. And you'll see that as an example, I did work on the Golden Ears Bridge that is here in the Lower Mainland. After that bridge has been put in place, another thing that is a major societal impact is that the travel time now for people to get to and from work has been drastically reduced. And because of that, people are able to spend more time at home with their families because their commute time has been reduced. Okay, so I'm now going to go back to my screen presentation. And actually, sorry, let me share this one here. I'm going to share with you now with some of the solutions that I have. And if you do still have some solutions that you want to propose on the chat, then feel free to do so. This is level 1. So if you were playing with this one, you can see that now I have built this truss structure. I can actually now run this truck across this structure. And if you didn't get a chance to do this during my presentation, you're more than welcome to do that after the fact. And then you can see that this is something that you can do very well. And then if I wanted to, I can actually go to, I'll show you what my level 2 is, which is this solution here. And I can actually now have a more complex structure and drive my vehicle over this structure. And in the interest of time, I probably won't have enough time to show you what number 3 looks like, but you can definitely try that out on your own. And I am now going to flip back to my presentation to wrap up and then ask to see if you have any questions. So I also ran this bridge building workshop in a different format if I was in person. I would ask for you to actually try out building these bridge structures with paper and glue stick, and that would be the only supplies you'll be able to use. And then I'll ask that you're going to be able to carry die-cast cars across that. I've actually run this bridge building workshop for both kindergarten classes as well as my university level classes, and I do have some very interesting response. And you can see that even with the kindergarten class, you can see that they have started to pick up on the importance of triangular shapes and structures, and they have used this in this particular case here. You'll see the bridge structure holding up very well across the gap, holding that die-cast car. But what I wanted to talk about is how impressed I was with some of the innovative ideas that even children as young as 5 years old will be able to come up with. This is the most interesting one I have seen, where the student just said, you know what, I'm just going to glue that piece of paper to the table. And now that adequately carries the vehicle across the bridge. So I have not even thought about that idea. So it is very important to think outside the box. Sometimes those are the best ideas. So that's all I want to leave you with. I want to encourage you to think of engineering as a helpful, innovative, and collaborative profession.